Hello, my name is Mario. Welcome to another video. In today's episode, I will be sharing with you another tip for building microservices in Go, specifically secure configuration using environment variables using Hashicorp's Vault. What is the agenda of this video? We have 4 items. We are going to be talking about some ways to configure services, why using environment variables, packages that I like to use for configuration, and I will show you the code that is using all of this live. What are some ways to configure services? There are 4 ways, in my opinion. One of them will be bundle the configuration with your artifact. For example, a config file, an XML, a YAML, whatever the case may be, is bundle part of the binary that you're going to be distributing or part of the artifact that happens to be maybe running in a Docker container. That's one way to do it. Another way will be using the CLI, passing in arguments to the binary that then the binary will be using for actually configuring the service itself. The other one, and this is the one that I like doing, is a combination of using environment variables that are injected during runtime and actually using the other two above, which is a combination of a sort of like a configuration file, not a real YAML or an XML, but also something that we can load through the CLI. And you will see that when I show you the code. So why even bother using environment variables? Well, there are a few pros and cons, like in everything in life in software development. The trade-offs here is that the pros is that it allows us to easily change configuration during deployments. You can literally keep the same artifacts, and then depending on the environment, you can change the database name perhaps, or maybe the password, or the username, or it maybe point to a different database itself, a different address, and it still use the same logic that happens to be living in your artifact that lives in your service. Nothing changes outside of that. It's just a different way to run the service. Obviously there are cons, and it depends on if you have a lot of configuration values. If you are trying to configure something that happens to have, I don't know, a lot of details, it's most likely using environment variables is not a good idea. And I will show you a way to sort of solve this. And it is not secure by default. What this means is that obviously if you're going to be using environment variables and you're going to be trying to pass in a password, for example, that is definitely not secure. Other than the key value data type that we have using environment variables, there is no data store for that. Not data store, but not an actual data type. And again, there are ways to, work it using Go package that I'm going to be showing you. But still, there are some limitations, and there are some good ideas right there. So let's look at the packages that I like to use for configuration. Again, using environment variables, and specifically a combination of the 3 things I just showed you before: a file that we're going to be bundled as in the artifact, a CLI for passing in some configuration values, and the actual environment variables that are going to be loaded dynamically depending on how we are running the service. There are a few of them. Obviously, the common example would be using getenv, which is included in the standard library, part of the OS package. It literally just pulls the value as is from the environment, and that's it. It's an environment variable, nothing overly complicated. Now, go.env is one that allows you to load a file that it also nowadays supports variable expansion, but it's literally just sort of like a port of the ruby.env project, if you're familiar with that one. But it's literally just it takes in a file, a .env. It doesn't have to be a .env, but the format is sort of like a key value, and it loads those values as environment variables in your process, in your binary. The other one is a little bit more complicated. It's called env-config, and this one allows you to use the same configuration using environment variables, but depending on how you name those environment variables, it will let you create a data store, and it will also allow you to transform the types from strings, which is literally the only thing that the environment variables support, to more strict Go types. And if you look at the example, you will notice that there is this my app, with a bunch of different names, and these are applicable to fields that are transformed to fields, and depending on the type that is defined in the field, in the type struct, it will try to transform and typecast those values to the corresponding value that is defined in the end file. So how does it work? If you're combining a bunch of different things together, how does it look like? I will show you next, but before that, one of the things that I like doing with them is I like wrapping all of those packages around a secure wrapper, which is the whole point of this video, showing you how you can still use environment variables, and a paradigm that I like to use for wrapping secure secrets, or something that you need to have stored in a vault, or some sort of service that is secure and not open to the public, literally, and then still using environment variables. So let's jump into the code to show you how this thing works. Compared to the previous version when I was talking about the project layout and the repository pattern, one of the things that I did was to refactor the way the Postgres database is configured, and now instead of using the database URL environment variable, that long string that was equivalent to the actual URL, the Postgres URL that included all the other values that are needed for connecting to the database, now we are defining specific variables for each one of the fields, and those fields are being pulled from the environment as environment variables. So the way it is right now, if you notice, is using this type called env-var configuration, and what this thing is doing is literally doing the first part, trying to get the values from the environment variable. And the important bit about this implementation is that I'm adding this paradigm that I also discuss in a blog that I will be linking in the description, that I will show you, that it shows you a way to somehow still define defaults, but if you happen to have a variable that happens to be has a suffix called secure, or you can literally call it whatever you want to call it, it would allow you to define some logic around it and perhaps pull the values from a secure a secure repository that happens to be storing only secure data, which in this case would be Vault. But there are examples. For example, in AWS, you can use the parameter store system managers, if I recall correctly, that's the name, and then you can pull and store secure data and pull the values from there. The idea is practically the same. The way it works is that as soon as you receive the name of the environment variable that you're trying to get, and again, if we go back to the file, you will notice that what I'm trying to do here, if I jump down, I'm trying to get the value for database host. Okay, and then I jump into the configuration and I'm trying to call get, and what configuration.get does is get the value from the environment variable, and then it tries to get a value that happens to be, again, using the suffix secure. If the value exists, it goes and pulls the value from the remote provider, which happens to be the secure data store handling all the secure data and all the secrets and whatnot. The implementation that I have right here, it's a Vault, and I'm running locally a Vault server that is going to allow you to get the values from that secure source. The way this type is implemented is that there is receiving the provider type, which happens to be implementing this get method. Then the Vault type, which is in the Vault package, is specific to the Vault API, is also implementing the get method. I will not go through the whole logic right here, but basically what it's doing is just defining a new key and then a path, and depending on the key, it will get the values from Vault and pass down those values back downstream to the actual server. And if I run this, one thing I want to show you first before running anything is the example without the Vault implementation. Let me see if I'm running. No, I'm not running the containers. So to run Vault, there is an instruction right here that I can use. Oops, oh, there's a typo. Okay, so if I run this, there is a Vault Docker container running right now. So the way Vault works is that there is a secret engine right here that is using the key value data, what is the name? They call it engine, the key value engine. And what we're going to be doing here is defining a path called database, and all of this is going to make sense in a moment. I just want to do it right here so you can see it. We're going to define username. The value will be user. The password will be, it's going to be password, and we're going to be saving it. Now the idea of this is that when we go back to the example using the secure environment variable, we will be able to pull the values from Vault. Let me show you. Now that everything seems to be configured, we're going to be running the same example using env example, which is this file, and it will be doing what we were describing last time. It will be going to the database and inserting a record. Now if I decide to, you know what, let's pull the values from Vault or from the secure data store, I can do exactly the same, and it will be inserting the values as before. Now a little recap in case I was going too fast. The way this works is, one, we are defining a data store in charge of connecting to our whatever service that is in charge of handling tokens or handling secure strings and those kind of things. That's one part. The other part is wrapping that using an interface type for loading the configuration that is coming from the environment variable, and then depending on whatever logic we decide to have, we can pull the values remotely from that provider. The way we are determining when to do that is when we find a variable that happens to be using the suffix underscore secure. If that exists, we go through the process. It doesn't have to be underscore secure, it can be anything. And that's one part. After that is we need to go and update our main file to, instead of using the long URLs, all the long form environment variables, to start using short form or concrete field-based environment variables. And that will allow you to it will give us more flexibility when trying to configure things. The other thing to call out here is that obviously this configuration, which is the important thing in Vault, is the token. That depends on how do you pass this token value around. That depends on how you're running your binaries. If you happen to be running a Docker container, maybe you can inject that when you are building the not the image, but more when you are configuring whatever is running that image. So if you're using ECS, which is in AWS, you can configure that via the IAM, or if you are using a different service, you can configure that in a different way. The whole point, again, because it's Vault token is literally the key to unlock the Vault, you need to consider that as a really important secure token value that you shouldn't be passing around, or make it explicit when the value itself is being run through the Docker container, for example. Okay, hopefully that makes sense. The way it is right now for development purposes and for demo purposes is that I'm doing it here much more explicitly. And hopefully all of that made sense, and if not, just leave me a comment. I will do my best to explain it. Again, as usual, the code is in the link to the code to the repo is in the description, so feel free to check that out whenever you have time. And as usual, thank you for watching, and I will talk to you next time. Don't give up, keep it up. See you.